Alrighty then.
Can you try to line it back?
No. I'm sorry. All right, class.
Yes.
Okay, good. Anthony, what's up? Okay. All right. Different integrals, method of substitution. Now, this one right here, we're going to have a lot of the same things that we've been doing starting out, and then we're going to go and make it the complicated ones easier. So the ones that are complicated we're going to learn a tool to uncomplicate it. So indefinite integrals have plus c. Indefinite integrals always plus c. Definite, that means I have an upper and lower bound. I am not going to have a plus c because I'm entering in values for those. This one right here, definite, always plus c. So that plus c will make the entire problem incorrect when you are actually doing the AP exam. So, important. Okay, here's some basic ones, the trig ones, the arc ones. These are in your notes, so that's important. Okay, where's the other one? So a to the x is going to be a to the x over ln a plus c. Where's the other one that we have? Ln x. So x to the negative 1, which is 1 over x, and that's going to give me ln absolute value of x plus c. So why am I adding absolute value to my answer there? What can I not have?
I saw the absolute part of it.
Yeah, why do I have that?
You can have negative.
Can't have negative in my ln's, right? So this is just some value, because it's not stated yet, of what it is. So you could plug in any value of x, and this still be true. But we know that there's a restriction on that, where I cannot have values there. All right. So, let's see. So, integral x to the fourth. What's that going to give me? X to the 5 over. Anything else? Plus c. There we go. It's not so bad, right? Okay. Now, I'm going to rewrite this next one. So that's going to be integral of x to the 1/2 dx Anthony.
X to the power of 1 and 1/2 over.
You use improper.
Like
3 halves.
3 halves.
Yeah, 3 halves. So you don't want to use the mixed number, especially for those. Because if you remember correctly, when I have an exponent that is a fraction, the top number of that fraction is my power, the bottom number of my fraction is my root. Does that make sense?
Yeah.
Okay, so that, yeah. So leave it like that. And then
It'd be 2/3.
very good. So it's 2/3 because I'm multiplying by the reciprocal, right? Because I should be dividing by 3 over 2. Multiply by 2 over 3. And what am I missing? Plus c. See? There we go.
So in this one, in these, there's no dx after the equation.
Yes. This right here, dx means that I am taking the derivative in terms of x, or antiderivative in terms of x. All right, so this next one here, I need to rewrite it first because this is, I don't like that. It's what?
Sin x, secant x. You write like that. Or that makes it hard.
So you're saying it would be sine
Times 1 over cosine squared x, which would be secant squared x.
sine x times, right?
Yeah, so that would probably simplify that out.
Okay. When we did derivatives, was this one of my answers? No. Okay, is there another way to rewrite it? Here, I'm gonna rewrite it like this so you can see it first. So sine x over cosine x times cosine x. So now I'm rewriting it, right?
One times cosine. One times cosine. Wait. No, it'll be
Secant what?
secant x.
Secant x. So that's secant x right here. That's secant x. What's this? It's tangent.
Oh yeah.
So what is secant tangent?
Oh, that's the antiderivative is
Secant tangent.
Oh,
So you guys have this page, right?
yeah.
Yeah, okay. So yeah, it's secant tangent. So that's going to be of secant. So it's like going backwards. So if I know the derivative of secant, I can try and keep that in my mind that derivative of secant is secant tangent. So antiderivative of secant tangent is going to give me secant. So with the trigonometry ones, when you see those, you might need to rearrange it to actually make it sine x over cosine squared. That's also secant x. If I were to just write it like that.
If it was secant squared x, then it would be cotangent. No, or no, tangent.
So, right? Are we okay?
Yeah, I get it. It's just I forgot those.
Hey, no worries, no worries. That's why we're going through it. All right. So just so you know, if you don't see this, there is a defining here. So I have two different things here. When I was reading through the notes, I'm like, what the hell? So it's basically the derivative undoes the integral. What's wrong? Okay. Okay. So derivative undoes the integration. And we could separate it if we have like this. We could separate it into two separate integrals. Sometimes it's necessary, sometimes it's not. But you should know that you should.
What were you doing on the other side? The one before? Yeah, that one.
This?
Yeah.
Just two things. So integral and derivative, they undo each other. It's like squaring a square root.
Integral is the dx and
Integral is like antiderivative, right?
So
derive the anti.
basically, yeah, derivative and antiderivative. When you put them together, it cancels out, and you're left with what's there. So, like I said, squaring a square root is going to cancel it, and you're left with what's there. So in math, everything has its opposite function. Okay, constant multiple, so whatever the constant is, I could take that out and bring it in front of my integral.
Could you also do that for stuff?
Riemann? Yeah, yeah, yeah. Just common factor, whatever I can get a common factor of. So this one right here, you don't really have to do common factors, but let's rewrite it first. Okay, I'm going to rewrite this. So this is going to be integral of 2x 1/3 plus 5 over x. So what I could do, I could separate it in two different and break apart. So I could say 2 integral of x to the 1/3 dx plus 5 integral of 1 over x dx. That's just basically what that coefficient is. That number comes out front. So it makes your math a little bit easier, doesn't it? That's all that does. So we're breaking up into two. But do I need to do that? No, I don't. So I'm going to use this one here. So this is going to give me 2 x to the 4/3 because I'm adding 1, right? I'm adding 1, so in this case I'm adding 3 over 3. So that's 4/3, and then what do I do? Divide by 4/3, but divided by 4/3, same as multiplying by? There you go, multiplied by 3/4 is the same. Plus, okay, 1 over x. Very good. ln of x. Am I missing anything? Plus c. Am I missing anything?
Well, you can simplify the fraction.
I could, but there's something else to make this true. Absolute value. Absolute value here is important. All right, I can simplify over here, so that's going to give me 3, x over 2 plus 5 ln of x plus c. Question, Anthony? Okay. All right, let's keep going. All right, I'm going to rewrite first before I try and do this. So if I rewrite this, that would be, let's see, integral 12x to the negative 5 plus x to the negative 1/2 dx. I could have separated it into two separate integrals, but that's not necessary. Just rewriting it first is probably going to be enough to actually help you out with this. All right, so antiderivative, so it's going to give me 12x to the negative 4 over negative 4 plus 1/2, because I'm adding 2 over 2, so it's x to the 1/2 over 1/2 times, right? And then what else am I missing? All right, just clean it up. I get negative 3x to the negative 4 and plus 2x to the 1/2 plus c. Now, this next part is going to be tricky. They intentionally put it like this, so you have to look at it. Now, this is how I want you to look at it, specific of this. What's the degree of the top?
2.
they're both 2, right? That's important. So they're both that. So that means that they had a common denominator. Had being past tense. So I'm going to rewrite it. So I'm going to rewrite it because they are the same degree. So I could rewrite it like this. I know this might look a little bit crazy, but they had a common denominator, right? And so I was able to combine them and put 1 plus 5 gives me my 6, right? So I'm going to separate it. So I'm trying to work it backwards to what the original problem is before it was simplified. Yeah, so right here, this is going to be integration of x squared plus 1 over x squared plus 1 plus 5 over x squared plus 1.
Integration of 1.
Yes. Now, do you see what we start, like, from here, it was simplified to this. We saw that there is a common denominator. Okay, with that common denominator, I was able to go the 5 plus 1, which gave me the 6 on top. And so you have to break it down in what you started with. So right now, we're at the end, and we have to try and break it up into parts that I could use. Now, my integration is going to look this. So same top and bottom, I get 1 plus 5 over x squared plus 1 dx. Now, is that manageable? Yeah, that's a lot easier now, isn't it? So, integration of 1 is x plus 5
Oh,
Is it divided? Is it divided by x to the third over?
Here, watch this, watch. I'm going to break this up then. So, let's go plus.
there we go. It's let's see. Tan inverse.
Inverse tangent, very good.
I
Very
recognize it. I was like, hold on.
Okay, so by rewriting it like this, you guys see that this gives me my inverse tan. So right here, that x squared plus 1, if it was just 1 over x, that would give me an ln, wouldn't it? Yeah. So that would give me an ln, but this is x squared plus 1, so there we go. So this is going to be an arctangent of x plus c.
Do you have to write arctangent or do you also just write tangent inverse?
So -1, inverse, yeah. Or, yeah, I try to use those terms interchangeably all the time.
Okay.
So if you were to write arc tangent, it means the same as that. So that's the reason why I say it and I write it all the time differently, because they are interchangeable. So you have to associate those two together.
So if it's like a problem like this and the degree is the same, you can always use that kind of method to.
Okay, yeah, we use that. I use that to see. I'm like, okay, if they're the same right there, I could probably try and find some common denominator out of it. Okay, so I I gotta try and separate it. The reason why I say that is it's simplified here to be 1. Could I have done it if it was an x cubed or something? I could have, but let's say it was an x squared plus could I have done this?
Yeah, like, yeah. Because you can factor in that.
There you go. So you have to look at it different ways. This one was an addition. Okay? If you look at it the other way, you'd be like, okay, I could factor that to try and simplify this before I could before I do my math, right? So we're trying to make the problem easier before I actually try and do my either integration or my derivatives or antiderivatives, all that other stuff. So that's the whole point, is actually trying to find a way. I got to look at the problem and try and see what tools I have to try and fix that. All right, new tool. Okay, so see all this right here? This is actually really good to read. Am I going to read it because you're not going to understand it? I'm not going to do that. So instead, I'm going to show you how it works. These are puzzles. U substitution is a puzzle. And it is a puzzle where we normally would have a chain. So if I look at it and see, okay, if I take the derivative, that would have a chain rule, right? If I take the derivative, that would give me a chain rule. So that's the tell me, that right there is going to tell me, I'm going to try and U sub that. So for my first one, integration of sine 3x plus 2 dx. So, Anthony, if you were looking at this and you said, hey, that's a derivative. If I take a derivative of that, I need to do what?
So that's a derivative if we're taking the derivative.
No. We're not doing the derivative. You're looking at it and you're saying, okay, if I'm doing the derivative of that, what would I have to do? I would have to do a chain, right? Okay, and so the chain part is going to be my U. So I'm looking at that, and that's one of the things that you guys already have been identified, chain rules. Like, okay, that's a good thing. So now this is the piece that's going to get it. So I'm going to take that. I'm going to say U is 3x plus 2. Now, we do take a derivative using the substitution. Using substitution, I'm changing the problem by taking the derivative of this. So this, the derivative of that is going to be du is equal to 3 dx. Now, you notice you have to write both the du and the dx down. Have to. Es muy necesito. Now, my substitution, I want to substitute and only have u's now. I got to get rid of my x's. Dx also counts as something that I have to get rid of, because I want to take the integration in terms of u now. So I'm going to do this. Divide both sides by 3. So I'm going to replace that equal sign. This is important. That equal sign. What is dx equal to now? du over 3, right? So I'm going to replace my dx with du over 3, or 1/3 du, right? Now, isn't that 1/3 just a coefficient, right? Okay. It can go in front of my integrand. 1/3 integral of sine of u du. Now I can take the integral of that. What is the integral of sine? Negative cosine, because I'm working backwards on that circle, right? So it's going to be a negative 1/3 cosine of u plus c. But do we know what u is? My u is that. So there we go.
How did you get du?
Du. So this is my u substitution, right?
Yeah.
Okay. What I did is I took a derivative of both sides. Because in our chain rule, when we're doing the u substitution, it was u and then it turned into u prime, right?
Yeah.
Okay. U prime is the same as saying du. So, but for the sake of writing it out for my integral, it's the same thing.
Okay, but shouldn't it just be 3? Why
No. Right here. So, because this is saying that I took the integral of u in terms of, derivative of u in terms of u, so it's going to be 1/3 du, right? Because there's a 1 in front of that. Remember when we did implicit, and it's going to be x squared plus y squared equals 1, and it would be 2x, right, plus 2y, and what did I have to add right there? Times dy dx equals 0.
Yeah.
This says I took the derivative of y in terms of x for this problem. This, I have 1 right there. So it's basically saying I have 1 times du with the derivative of u.
So
And then, you ready? Here, I'm going to probably blow your mind right here. So if I did this and said 3, the derivative of u in terms of x is 3.
yeah.
The derivative of u in terms of x is 3.
Yeah.
Instead of actually just writing du dx is this, I have the du on the left and the x on the right. So I'm going to have an integration on the left, and I'm going to have on the right.
Oh, you put the du. You put the dx on the right, and then.
Yes. Because this over here on the right-hand side is in terms of x,
Yeah.
and the left-hand side is in terms of u. And so because I'm getting rid of all my x's, I don't want x's over there, because I have to substitute out all my x's
Yeah.
before I can take the integral in terms of u. It's going to get crazier on this next one too.
Okay. I also have did you already finish the problem?
Yeah, it's right there. Because it was u here. And then we knew what u was, so I plugged it back in. And so after I'm done, I put it back to what my answer is.
Oh, okay.
So basically, we derive though, you do du over dx equals 3, and then you just move it around.
Yeah.
Dx equals.
Yeah. And so, yeah, if we were to go back and doing it like implicit, like we were doing, it would say du dx is equal to 3. but then I want to get rid of my dx. And so that's why I'm separating them to be one on each side. Yeah.
For the slide back, where did no, not that one, the one where it's all the words slide back. Where did the
2x. You'll see it in a second.
Yeah.
Yeah. So that's the next problem right here. That's this. And you'll see it here. So x. So as long as we're not playing on our phone, we're writing this down. And we're like, oh, hey. All right, you ready, Blade? If I'm looking at this and I'm like, hey, chain rule, where would I start with there? Which is? Okay, let's say u is, sorry. All right, and so now what I'm going to do?
You're gonna find through in terms of u.
So it's going to be du is equal to 2x dx.
You're gonna divide both sides by
2. 2.
Oh, 2.
Okay, remember, I said I want all my x's over here, right? So 1/2 du is equal to x dx. That's why this is a puzzle. My 1/2 du is equal to x dx. X dx. So I'm replacing x dx with 1/2 du. 1/2 out front, my integrand. So it's going to be u to the 1/2 and du. Because all this inside here became my u. So my 1/2 du replaced an x and the dx. Does that make sense? Does that help you with the long explanation one? That's the reason why I didn't want to go over the explanation one yet. So that's why I had to show you what it is. This is a puzzle, and so it's going to replace that extra x I'm missing. So by rewriting it, that x is gone, the dx is gone, and I'm replacing it with 1/2 and du. Yeah? Okay. So that's going to give me 1/2 u to the
U to the 3
times remember, we normally divide by that new number, right? We would divide by 3/2, but we're not divided by 3/2. Let's multiply by the reciprocal. Very good. 2/3 plus c. So 1/3 u 3/2 plus c. But do I know what u is? Yep. I do. So my u is going to be x squared plus 1 to the 3/2 plus c. And I'm going to try it. I got 5 minutes for this one here. I want to try and get it before you guys leave. So same thing with this one. This one's e to the x e to the root x over root x.
Is this changeable as well?
Yes, it is. All right, when we had changed and we dealt with the e's, right? I would always just take whatever's up there, right? So u is x to the 1/2. So du is equal to 1/2 x dx, like that, to the negative 1/2. Yes?
Yeah.
So I'm going to rewrite it. du is equal to 1 over 2 times 1 over x to the 1/2 dx. Now, there's a reason why I rewrote it like this. Isn't that exactly the same way it's written on top? Okay. So let's see what's being taken out. So that means in this case here, I'm going to multiply by 2. So that's going to take care of that. So 2 integrand, or the integral from, let's see, over here, I'm replacing 1 over x to the 1/2 dx with 2 du. So 2, and then right here left with e to the u du. That's going to give me 2 e to the u plus c. And since we know what u is, so 2 e to the x 1/2 plus c. All right, that's it.
Is that a proper answer? Like 2e x to the 1/2?
Plus c, yeah. Should I put a little box around it?
No,
With that, with,
I didn't know you could have like an exponent to an exponent.
Yeah,
The final
yeah.
answer.
Yep. All right. That being said, like, share, and subscribe. There is advisory today, so if you guys want to come in and work on this, I highly recommend, because you're probably going to have trouble getting these puzzles started. It's identifying what your u is.